Hey everyone, welcome back to my channel. Today we are going to solve a medium problem on lead code, minimum operations to make a uni-value grid. Let me read the problem statement. You're given a 2D integer grid of size m times n and integer x. In one operation you can add or subtract x from any element in the grid. A uni-value grid is a grid where all elements of it are equal. Return the minimum number of operations to make grid uni-value. If it is not possible, return -1. Got it. Okay. So we will be given a 2D array and we'll have to make some operations such that in minimum operation we have to make all the elements equal. So the operation is defined as add or subtract x from number any number of times from a number. This is an operation defined, and if it is not possible to make all the elements, then we have to return -1. First, can we tell for a given element if it is possible to tell to make all the values equal to some equal number or not? So first, let's say there is a number ai and ai1 a0. Let's say these are the elements in the given number, i0, i1, i2, and so on, in. Let's say we have to make all the elements to some let's say some k. Okay. Okay. Using this operation, right, to make i0 is equal to k, what we can do is plus some z number of times x, right? After operation, if you are making 0 operation, then I is equal to k. If you are making some number of operation, this will be right like this one. If we resolve this, z times k is z times x equal to k minus i0, and this if that is the case, and this k minus i0 should divisible by x, right? K minus i0 divided by x. If it does not divide x, let's say we get some remainder, right? And this remainder should be equal to each element, because we want to make it since we want to make the element as same, so that is why what we can do is what we can say is this remainder what we are getting here, it should be equal for all the elements, which is nothing but instead of this one, this can be written something like I1. uh, so uh, so for all the elements based on this formula we can check if the remainder is not equal, then we can say directly return -1. Let's say if the answer is possible, how we can make, like, which element to choose such that all the elements equal to that the minimum, the, the in the result there will be minimum operations, right? If we see the numbers, if we take the minimum element uh, like 2, uh, we will have to make the maximum element to equal to 2, it will take more operations. Similarly, if we take the maximum element, uh, the minimum number will take more operations, like keep adding x to make it 8. So we have to select somewhere in the middle element, the median. We can also say that average can also be taken, right? But if we take an average, we might get an element which is not present in the array, and if we do that, you will have to do unnecessary operation for that average element, because since that is not present, we'll have to make all the elements equal to that average number. So if we take an element in that present which is present in the array, we will be making 0 operation for that median element, but for the average element we will make extra operations. So median will be the choice. So our the equal element should be the median in this case. How will you find the median? uh, we know the median, right? If we sort the element and take the middle element, which will be the median, which is by the definition. And since we only need the middle element, which is we can do, instead of sorting, we can do a quick select, uh, such that we don't have to sort entire array. We just have to, where the pivot is equal to the middle element, then all the elements on the left are less and all the elements are on the right will be greater than the pivot element. So we can use a quick select algorithm to find the median. In this video I will go with simple sorting based approach. If you want me to have a tutorial on quick select, I will make a video, because to code this up it will take some time, but which is an easy one. If you know how the quick sort works, it is very easy to implement it. I will make a separate video such that you can solve using quick select. The average time will be big O of n. In the worst case it will be n square, but average case is big O of n. So let's try to solve this one. Let's code this up first. First we will transform the array into linear array instead of two-dimensional array. So we will declare nums of size will be grid dot length times grid dot this will be the size of the array. So we will define the size. We will loop over all the elements. I less than grid dot length I plus plus now we have flattened the array, like transform the array. Now what we are going to do is arrays dot sort of nums, and in the this will sort the array in increasing order. Now we will take the median. Let me declare is in where median is equals to nums dot size divided by 2. This will be the median. Now when in nums, if median modulus x is not equals to num we can directly return -1 in this case. Here in this case, this is a median. Then this should equally divide median and so this is the one. Now minimum operations will be minimum operations is equals to num minus median divided by x, and this should be my absolute value because we are calculating operations, right? So in the end we will return minimum operations. Yeah, basic test case for pass. Let's try to submit this one. Accepted. Let's analyze time and space complexity of this solution. We are declaring an extra array of let m and n be the size of the grid, and like number of rows and number of columns, that will be n times m, and that will be extra space here, and we are doing n times m here, and what we are doing is we are sorting it. It will take n times m of log of n times m for a primitive data types. Java used under the hood quick sort with some variation, and space of log of m but overall m times n, which is bigger, and we are doing some m times n operations of here. So this will be overall, it will be n times n log of n and n. This is the overall time complexity. So if you Please let me know if you want me to make a video on fixed select. Like instead of arrays dot sort, what we can do is uh, fixed select. uh, we can do something like where median is equals to nums comma uh, size by 2, which is nothing but kth element, finding the kth element in the given array, uh, where k is equals to size by 2 and find kth smallest element in the array. If we want me to have a video on quick select, please let me know in the comment section. I will make a video on that. Basically this is the best algorithm to optimize this part. Instead of sorting entire array, we just need the only one element that position, like the kth smallest, which is the middle element in this case. So please let me know, and thank you for watching my video. Please like, share and subscribe, and see you in the next video. Bye.